So we have another one here with a log. All the bases here are the same, which is really handy. So I don't have to do any change of base for this. But what I am going to do is to put all the logs, or all the things with x's, onto one side of the equation, and everything without an x can stay on the other side of the equation. So I'm going to have log 5x, and I'm going to add on log 5 6 minus x onto the both sides actually, and I'll leave log 5 8. Now because the bases are the same, I can multiply that one with the 6 minus x, and it equals log 5 8. The 8 is going to equal to this. They're both log base 5s, so I don't have to change the log bases. And I'll expand on this side, and it gives me 6x minus x squared equals 8. It's now a quadratic equation. I'm going to make that quadratic equation equal to 0. I think this will factorize into minus 4 and minus 2. And it looks like my answers are 2 and 4. But what I'm going to do is I'm just going to go back to the top and check that 2 can be put into this logarithm here. Can I make x2 and can I make x4? Yes. Can I make x2 and can I make x4? Yes. What I'm looking for in here is that I don't get a negative number or a negative number here, because then I wouldn't have a logarithm. So the one on the right side, really similar actually, very similar. So for this one, I'm going to put the logs together. They've already got all the x's on one side, and I can times this bracket. Sorry, divide, because it's a minus, and it equals 4. Two ways of doing it. I could change that 4 into a logarithm base 2, or I could simply take what I've got and rewrite it as an exponent. So it becomes 2x plus 7 divided by x equals 2 to the power of 4. So it becomes 2x plus 7. Now 2 to the power of 4 is 16, so it becomes 16 x's. Take away 2 x's from both sides. Divide both sides by 14. 7 over 14 is a half. So there's 2 more examples of using log equations.